So first problem is, a farmer has to plant two kinds of trees P and Q in a land. 1x plus 2.5y less than or equal to 4000. So here we have one table. So using this table we can construct LP model. If liquid product sell for 3 rupees per jar and dry product sell 2 rupees per carton. Hello everyone, welcome back to my new session on Operation Research. I'm Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. In my last session, I have discussed about LPP problems, Linear Programming Problem. Linear Programming Problem is a real-time situation for some data. How to solve a real-time situation using linear programming? So with the help of mathematical model, we can create LP model. So today, I will discuss LPP problems. So first problem is, a farmer has to plant two kinds of trees P and Q in a land. That means, if you get any keywords of manufactures, a company manufactures, creates and produces, so definitely that problem is maximization problem. So if you get maximization problem, all the constraints should be less than or equal to availability of the product. So if you get any minimization problem, so all the constraint value should be greater than or equal to the availability of the product. So this is for maximization and this is for minimization. So first you need to check whether it is maximization problem or minimization problem. So first we have, a farmer has to plant two kinds of trees, that is tree P and Q in a land of 4000 square meter area. In a land of 4000 square meter area, in the sense, in a land of 4000 square meter area, we have two trees called as P and Q. So tree P and Q. So here, each tree P requires 25 square meter and each tree Q requires 40 square meter of land. The annual water requirement for each tree P is 30 units and for each tree Q is 15 units. At most 300 units of water is available annually. So 3000 units of water is available for tree P and for tree Q. And it also estimated that the ratio of the total number, listen carefully, it also estimated that the ratio of the total number of trees Q to the number of trees P. Q to the P means, for P, I will take the decision variable as X and Y, X and Y. So here, the ratio of the total number of trees Q to the number of trees P should not be less than 6 by 19. So for Q, I will take this Y and for P, I will take X. The ratio of the total number of trees Q to the number of trees P should not be less than. Should not be less than means it should be greater than 6 by 19. And should not be more than 17 by 8. So Y by X should not be more than means it should be less than 17 by 8. So here they have given the product details. So first you have to write the given value and the return per tree from P. So return means they are expecting the maximum profit. So the return per tree from P is expected to be 1.5 times. So return is 1.5 times of P. So Z max is equal to, the return per tree from P is expected to be 1.5 times as much as from Q. So the return from P is expected to be 1.5 times as much as Q. So X means I have considered it as P and Y means it is Q. So 1.5 times, 1.5 times means 1.5x plus Q means it is Y. So this is my objective function. So first you have to write the products, that is trees, and we have P and Q trees. So first write the availabilities and given values and just write the objective function. So first step is objective function. So Z max is equal to 1.5x plus Y. And subject to constraints. So what are the constraints we have? So 25x plus 40y less than or equal to availability for tree P and Q is 4000, less than or equal to 4000, and 30 plus 15, 30 plus 15 less than or equal to 3000. So these are the constraints for a given value. So first write the profit, so Z max, that is objective function, and next you have to write the constraints, subject to constraints. We have two constraints here, 25x plus 40y less than or equal to 4000, that is availability of area, and 30 plus 15 less than or equal to 3000. So this is your constraints, and finally we have two more constraints called y by x is greater than or equal to 6 by 19 and y by x is less than or equal to 17 by 18. So next one, y by x greater than or equal to 6 by 19 and y by x less than or equal to 17 by 8. So these are the constraints of a given model. And finally, where x, y greater than or equal to 0, non-negativity restriction. So we have objective function, that is Z max is equal to 1.5x plus y, and subject to constraints, we have 4 constraints here, and where x and y, so we have two decision variables called x and y. So x and y should be greater than or equal to 0, that is non-negativity constraints. So this is your LPP model. And the next problem is a company produces. So company produces in the sense it is maximization problem. A company produces two types of tables, T1 and T2. Table name is T1 and T2. Materials is tables. Company produces two types of tables, that is table 1 and table 2. It takes 2 hours to produce the parts of 1 unit of T1, 2 hours to produce the parts of 1 unit of T1, and 1 hour to assemble and 2 hours to polish. 1 hour to assemble, that means for producing the parts of T1 it will take 2 hours and 1 hour to assemble. So for assembling will take 1 hour and 2 hours to polish. For polishing will take 2 hours. That is for table 1. And it takes 4 hours to produce the parts of 1 unit of T2. For producing the parts will take 4 hours for table 2 and 2.5 hours to assemble, 2.5 hours to assemble the table and 1.5 hours to polishing the table. So 1.5 hours. So 1.5 hours to polish. So first you have to write the detailed instruction about the raw materials. So first you have to write the table like this, and per month 7,000 hours are available for producing the parts. So per month 7,000 hours are available. So hours are available means hours availability is hours availability for both the tree T1 and T2. That is, per month 7,000 hours are available. 7,000 available for producing the parts and 4,000 hours are assembling, 4,000 hours for assembling the parts, and 5,500 hours for polishing the tables. So, first write all the availability for the products, for parts, for producing the parts, and for assembling the parts, and for polishing the tables. And the profit per unit. They have given the profit value here. So, profit per unit. Profit per unit of T1 is $90 and per unit of T2 is $110. So, they have given the profit and how many of each type of tables should be produced in order to maximize the total monthly profit. So, here have to find the profit. They have given the profit of table 1 and table 2. So, first write the objective function. So, objective function is Z max or P. P means profit, or you can write this Z max. So, Z max means maximization is equal to 90. I will take X, decision variable, X and Y. So, 110Y. So, 90X plus 110Y is my objective function. Z max is equal to 90X plus 110Y. And subject to constraints. Subject to constraint is 2X plus 4Y less than or equal to availability is 7,000 and 1x plus 2.5y less than or equal to 4,000 and 2x plus 1.5y less than or equal to 5,500. I'll write the constraint 2x plus 4y less than or equal to 7,000 and x plus 2.5y less than or equal to 4,000 and 2x plus 1.5y less than or equal to 5,500. So, these are the constraints value. And so, finally, where x, y greater than or equal to 0, this is non-negativity constraints. So, objective function, subject to constraints and non-negativity constraints. So, this is about your maximization problem. So, next I will explain about the minimization problem. So, I have discussed so many maximization problem. So, please practice well, easily you can score in LPP. The next problem is, a agricultural research institute recommended a farmer to spread out at least 5,000 kg of phosphate, fertilizer and not less than 7,000 kg of nitrogen fertilizers. Here we have two mixtures. So, first write the mixture's name. So, we have 5,000 kg of phosphate and nitrogen fertilizer. So, first write the mixture's name. So, mixtures phosphate and nitrogen fertilizer. Phosphate fertilizer and nitrogen fertilizer. And not less than 7,000 kg of nitrogen fertilizer to raise the productivity of his crops on the farm. There are two mixtures, that is A and B. So, we have two mixtures called A and B, weighs 100 kg each, from which these fertilizers can be obtained. So, we have two mixtures that weighs 100 kg each, from which these fertilizers can be obtained. So, from this fertilizers can be obtained. Each mixture weighs 100 kg and the cost of each mixture. So, next you have to write the cost of each mixture. Here we have two mixtures called phosphate and nitrogen, and we have two mixture A and B is 40 and 25 respectively. And the cost of each mixture A and B is 40 rupees and 25 rupees respectively. So the cost they have given here, the cost of each mixture is 40 rupees and 25 rupees respectively. And mixture A contains 40 kg of phosphate and 60 kg of nitrogen. Mixture A contains 40 kg of phosphate and 60 kg of nitrogen, while the mixture B contains 60 kg of phosphate and 40 kg of nitrogen. 40 kg of nitrogen. This problem can be represented as a linear programming problem to find out how many bags of each type a farmer should buy to get the desired amount of fertilizer at the minimum cost. So this is a minimization problem. So here we have to find how many bags of each type a farmer should buy to get the desired amount of fertilizer with minimum amount. So they have given the cost value for each product A and product B. So cost is 40 and 25. So first write all the given values, and also you have to write the minimum values of mixture A and mixture B. So here farmer to spread out at least 5000 kg of phosphate, 5000 kg of phosphate and not less than 7000 kg of nitrogen fertilizer. So that means that is a minimum cost. Minimum cost of each product is 5000 and 7000. So this is your given values. So first write all the given values using mathematical model. Then you can construct LP model. So what is the first step? So first you have to check whether it is minimization or maximization problem. Then you can write this mathematical model and you can use the LP model method. So this problem is minimization problem. So Zmin is equal to, so cost is 40x. I will take two decision variables x and y. 40x plus 25y. This is my objective function. So this is minimization problem. Zmin is equal to 40x plus 25y. And subject to constraints. So first write the constraints value, and 40x plus 60y. So this is minimization problem. If it is minimization problem, you have to use greater than or equal to availability of the product. So 40x plus 60y greater than or equal to 5000. So this is minimization problem. You need to use this greater than or equal to symbol. And second constraint is 60x plus 40y greater than or equal to 7000. So these are the constraints values. So first write the objective function. This is Zmin, minimization problem. So 40x plus 25y is my objective function. Then next write the subject to constraint. And finally, where x comma y greater than or equal to 0. X comma y greater than or equal to 0. So this is your LP model. So first construct the mathematical model, and easily you can find the objective function, subject to constraints and non-negativity constraints. Next problem is, so here we have one table. So using this table we can construct LP model. So first you have to understand whether it is minimization or maximization problem. A person wants to decide the constituents of a diet. It is diet problem which will fulfill his daily requirements of proteins, fats and carbohydrates. We have three different requirements called proteins, fats and carbohydrates. At the minimum cost, they have given the minimum cost per unit. they have given the minimum cost of each product. We have 4 different types of food: food 1, food 2, food 3, food 4, and availability of this product. So the choice is to made from 4 different types of foods. The yields per unit of these foods are given in this table. So using this table, you can construct ALP model. So here they have given the product's requirements. So here they have given the food type. We have 4 food types and we have 3 requirements, and they have given the minimum cost per unit. They only mention the requirements, protein, fats and carbohydrates at the minimum cost. So it is minimization problem. So first write the objective function. So Z-min is equal to 45x1 plus 40x2 plus 85x3 plus 65x4. 45x1, 40x2, 85x3, 65x4. This is my objective function. So first write the objective function and subject to constraints. Next write the subject to constraints. We have 4 different products. We have 4 different food 1, 2, 3 and 4. So I'll write the subject to constraint. 3x1 plus 4x2 plus 8x3 plus 6x4 greater than or equal to availability is 800. So it is minimization problem. So constraint should be greater than or equal to availability is 800. So first constraint, and the second constraint 2x1 2x2 plus 7x3 plus 3x4 greater than or equal to 200. And the third constraint is 6x1 4x2 7x3 plus 4x4 greater than or equal to 700. So these are the constraints. So where x1, x2, x3, x4 greater than or equal to 0, which is non-negativity constraint. So first write the objective function, subject to constraint and non-negativity constraint. So this is about your minimization problem. The last problem in minimization is a person requires 10, 12, 13 units of chemical A, B, C respectively. So here we have 3 chemicals called A, B and C. 10, 12 and 13 units. So chemical per unit is 10, 12 and 13 units. For his garden, a liquid product contains, so here we have some products. Some liquid products contains 5 to 1 units of A, 5 to 1 units of A respectively per jar, and a dry product contains 1, 2 and 4. So here liquid products and dry products. Dry product contains 1, 2 and 4 units of ABC per carton. If liquid products sell for 3 rupees per jar and dry products sell 2 rupees per carton. So they are selling the product. Liquid products sell for 3 rupees per jar and dry product 2 rupees per jar. So first write all the given values. How many of each should be purchased in order to minimize the cost and meet requirement? Here they are minimizing the cost. So it is minimization problem. So first write the objective function. So Z-min is equal to, so they are selling for 3 rupees and 2 rupees for dry product. Liquid product for 3 rupees, dry product for 2 rupees. So here I am using 2 decision variables called X and Y. This is my objective function zmin is equal to 3x plus 2y and subject to constraint. For 3 products A, B, C, liquid 5 rupees, dry products 1 rupees and chemical per units is 10 rupees. So 5x plus y greater than or equal to 10. Why it is greater than? Because it is maximization problem. And the second constraint 2x plus 2y greater than or equal to 12. And the third constraint x plus 4y greater than or equal to 13. So these are the constraints. So lastly, we have to write the non-negativity constraint where x and y greater than or equal to 0, non-negativity restriction. So this is about your LP model. So this is your LP model. By using the real life situation, we can construct LP model easily. So first we have to check whether it is minimization or maximization problem. And next you have to construct a mathematical table and easily you can prepare LP model for a given value. So this is about your linear programming problem. With this, we have end of this unit 1. In my next session, I will come with a second unit called unit 2. So I will continue this LPP model by graphical method. Thank you.